All right, how do we actually run the regression in Excel? What we have here is two columns. The first column is the prices, the second column is the demand. So this is our independent variable and this is our dependent variable. And we're going to make a regression model using these two variables, demand being our y variable, price being our x variable. Again, we could have multiple x variables. Let's try to do the one with the one x variable for the time being. When I have only one x variable, actually, before running the regression, I usually like to see a scatter plot. How you can do that is select your data sets. Again, this works only when there is one independent variable, one independent, one dependent. You can go insert, chart types, scatter. Okay, what you see here is the scatter plot of, on the x-axis you have price and on the y-axis we have demand. Let's change the axis titles here. This is price in dollars, and this is demand, and this table, let's name it price and demand. Okay, so if you have only one independent variable, you can actually run the regression without using data and analysis add-on. All you have to do is add trend. You have to select one of these points, right click, add trend line, and you can do linear. You can add display the equation on the chart and maybe display the r squared on the chart. Again, linear. We are only after linear regression. You do that, you'll have the regression model printed here. So it's nice and just on the graph itself. The actual way of doing, if you have more than one independent variable, what you should do is you should go data. On the right hand side you have data analysis add-on. If you don't have this, you have to go ahead and add it. To do that, click on the green button, options, add-ins, and you can go ahead and add what you need. Okay, I already added my data analysis tool. So data analysis, regression. Okay, now I select my y variable. I already have selected, but let me go ahead and do it again. My y variables is the second column. I select my y variable here. Again, to select my x variables, click here. Yeah, I already did it, but I'll do it again here. This is my y variable. Okay, now confidence level, you can change it to 95 or 99. That's up to you. Usually people do it 95%. That's standard. You want the labels, but that's good enough, right? All right, let's not add any bells and whistles for the time being. Okay. All right, this is the output you'd get. So first thing you want to check is your r squared here. So 0.866. If you have more than one independent variables, you probably want to check adjusted r squared. It accounts for the fact that there are multiple independent variables. So adjusted r squared is the more important one than the r squared when you have, but in this case, when there's only one independent variables, they are same. All right, now you want to go look at the last two, in this case last two columns, this last table here. What you see here is the first one is always intercept, right? That is your B1. In a model, this is the first value, 10.13. Then you will have each of your independent variables will have its own row. We have only one independent variable, that's why you have only one row. Next thing you want to check to see if your model, if your particular independent variable is, what is the, you want to check what the confidence level of this independent variable is. There are many ways to do it. One of the simplest way is look at this lower and upper value. And again, you can do it looking at the standard error. You can look at using the t-stats. Usually you want the t-stat further away from the 0. So minus 14 is pretty far. If it's further than about 2.5, that's good. If this value is further than minus 2.5 or plus 2.5, it's pretty good. Another way of looking at it is look at the lower and the upper. If your coefficient is between these two values, that's good. Again, here the lower confidence is 9.51, upper confidence is 10.74. Our value is at 10.12. That means the model is pretty sure about this value. That is it. And similarly, in this case, the lower value is minus 1.02, upper value is minus 0.7, and our value is in between those two. Any of this method is okay, and we'll talk about this as we go further later, but that is really that's not too much important for now. Now you can make your model. Let me write the model here. Let me go to home here. Let's merge. So our model is our independent variable, that is demand equals to first your intercept value, that is 10.13. That is saying if all your independent variables were 0, this is what your demand was going to be. Well, minus 0.89, well, just let me write let's round it up to 0.9 times your price. So we have a model. You give me a price, I can give you what the demand is going to be for that. So you give me the demand, you give me the price, I can give you the demand. All I have to do is 10.13 minus 0.9 multiplied by price. If my price is 0, this part is going to be 0, and the demand is 10.13. If the price was 1, 10.13 minus 0.9, and so forth. That's all there is to regression.